Alright, we are now moving on to amines within this chapter. Amines are compounds that have nitrogen in it. Think of NH3. NH3 looks like this, with 3 hydrogens coming off of the nitrogen. If we look at nitrogen on the periodic table, fluorine, oxygen, nitrogen. If we count the big rows over, nitrogen is in the 5th row, meaning it has 5 dots around it, meaning 5 electrons. 2 of the dots are paired up, and so those will react, but not in the normal sense. We are going to talk about that in later on. But then we have 3 single electrons that go out and form bonds. Now this is ammonia, NH3. If we replace one or more of these hydrogens with some carbon-containing group, which is also called an alkyl group, then we have an amine. Just like what we did with the OH groups, the alcohols, with the primary, secondary, and tertiary alcohols, we can have the same question about amines if it's a primary, secondary, or tertiary amine. This time you're going to look at the nitrogen, and then you're going to look at the compounds that surround it. Because there's only 1 carbon attached to the nitrogen, it's a primary amine. This one has 2 carbon. That's why it's secondary. Finally, we have 3 different carbons attached directly to that nitrogen, meaning it's tertiary. Whether it's primary, secondary, or tertiary is actually going to affect how it reacts and how it interacts with water, reacts with compounds, and interacts with other compounds. Just to give you a reminder of how they look as a skeletal structure rather than actually writing it out, you'll notice this means it's connected to the nitrogen, and every time it bends and it ends without something else written here, those are carbons. We only care about what's directly attached to the nitrogen. Since we only have 1 carbon directly attached to the nitrogen, it's primary. Whereas we have a carbon here, a carbon here, and a carbon here directly attached to the nitrogen, it's secondary. And here we have carbon, 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 meaning it's tertiary. It doesn't matter how many total carbons, just how many that are directly attached to the nitrogen. So when we start naming the amines, what you're going to do is you're going to think of it as a substituent. Since this is ethyl, it's called ethylamine. This has a methyl group here and a methyl group here. So it's because there's 2 of them, dimethylamine. And this one is methyl, methyl, ethyl. You do it alphabetically. Notice that ethyl is first. We do not take into account that di when we're naming it as far as alphabetical. It's before the prefixes. So ethyl, then dimethylamine. So let's try naming a couple and determining whether it's primary, secondary, or tertiary. First of all, we have 2 hydrogens. Those aren't counted, but we do want to include the rest of the carbons. Well, because there's 3 carbons here, this is a propyl group. So propylamine. Now, if you look at how many carbons are bonded to this nitrogen, there's only 1, so that means it's primary. Here, we have 3 groups attached to the nitrogen, which means it's tertiary. These 2 are methyl groups, and this is an ethyl group. Alphabetically, it's ethyl. There's 2 methyl, so it's dimethyl. And then followed by amine, because it's a nitrogen compound. Now we have aniline. Aniline is a benzene ring, which remember can be drawn like this, or with a hexagon with a circle in the center, and it has a nitrogen attached to it, where a hydrogen ordinarily would be. Notice on the first one, the substituent is on the nitrogen. It's not on the benzene ring. Therefore, they signify that with an N. So N-methyl means that the methyl group is on the nitrogen, and it's an aniline. Whereas in the last one, here's your aniline. The chlorine is bonded to the benzene ring instead. So here's aniline. 1, 2, 3. On the third carbon of the benzene is the chloro group. So let's look at some names here. We have a methyl group here, and we have an ethyl group here, and that's all we have for substituents coming off of nitrogen. So that's going to be named ethyl methyl amine. For this one, we have an ethyl group here, an ethyl group here, and a methyl group. So it would be diethyl, because there's two of them, methyl amine. And then finally, this is just simply aniline. Now, when we're looking at the periodic table again, here's fluorine, that's the most electronegative. Oxygen's right next to it, and that's been the primary other element that we've been talking about up until now. Then we have nitrogen. Notice nitrogen is just slightly farther away from fluorine than oxygen is. That means it's still electronegative, but not as much as oxygen. So when we talk about these interactions here, there will be interactions, but it's going to be less than that of fluorine. So we will have hydrogen bonding, but it won't be as much as fluorine or oxygen would do. And you have to have hydrogen on that nitrogen in order to have that happen too. That means if it's a tertiary amine, it's not going to have any hydrogen bonding, which means it's not going to have any of that added attraction, which means it's not going to dissolve as well. So primary and secondary amines do dissolve in water because of this hydrogen-oxygen interaction and this nitrogen-hydrogen interaction. But tertiary amines, because there's the lack of this hydrogen, will not have attraction enough to dissolve. So, which compound cannot form hydrogen bonds with other amines? Well, that means it has to be at least a primary or a secondary amine in order to dissolve, in order to have hydrogen bonds. Well, here is a primary, so that one's going to dissolve. This one's a secondary, so that's going to dissolve. This one doesn't have any nitrogens in it at all, so letter C is not going to form hydrogen bonds. So which one is not soluble? Once again, because this is primary and this one's secondary, it's going to dissolve. But the last one won't, because there's no carbon. That's not even an amine. Alright, so let's take a look at how they act as acids and bases. When we were talking about acids and bases earlier in the year, we talked about the fact that there's a lone pair up here for NH3. With the lone pair on nitrogen. Because of that lone pair, when it reacts with water, it can attach itself to the hydrogen, and the hydrogen gives up its electrons to oxygen. And that's why you now have NH4 rather than NH3, because the nitrogen took the hydrogen. And in the process, when that hydrogen lost its electron to oxygen, the OH group got a negative charge because it now has hydrogen's electron. But that means hydrogen lost its electron, and that's why it's positive. That's when it's reacting as a base. Because instead of donating a hydrogen, it's collecting a hydrogen. Similar thing happens when we're talking about amines. The only difference now, instead of it being NH4, it's the same compound as when it started. You are adding another hydrogen. So the actual process is the same. CH3, hydrogen, hydrogen, and then reacts with water. The nitrogen takes the hydrogens, and then the hydrogen gives up its electrons. Once again, you still have that negative charge because that electron that making it negative used to belong to that hydrogen. And that nitrogen went from NH2 to NH3. So you're still collecting a hydrogen, so it's still acting as a base by removing a hydrogen. So if it started off as methylamine, it's now methylammonium ion. That is the difference in naming. So amine salts are used quite often in medical and in everyday life. For instance, by adding citric acid to fish, you're actually neutralizing the fish and getting rid of that smell. So you're replacing the amine with an ammonium, just as you did with the other one, just as you did with this reaction. So methylamine goes to methylammonium. Dimethylamine go to dimethylammonium. After that, you're just going to say what the anion is. So this negative part that's in there now. So that's a chlorine, so that becomes dimethylammonium chloride. Methylammonium chloride. And that's what's making it a salt. A plus and a minus interaction. So amine salts are actually used on a regular basis. They're typically solids, they're soluble in water and bodily fluids, which isn't good because they're in a lot of medicines, and they're used when we're dealing with prescriptions and whatnot. So for instance, here is ephedrine. We have the positive there, the negative there. That's what's making it a salt. Ephedrine hydrochloride. That's in Sudafed and other medicines for congestion. Diphenhydramine hydrochloride is Benadryl. Alkaloids are the nitrogen-containing compounds produced by plants. For instance, cocaine is big in it. It's also in anesthetics and antidepressants and caffeine, things that interact with the central nervous system. So for instance, when we're talking about cocaine specifically, this is the compound that's actually extracted from the plant. Mix it with hydrochloric acid, and this is what is produced by it when you mix it with hydrochloric acid. Here's the negative and the positive, and then you react it with sodium hydroxide to form the crack cocaine. What's happening here, you notice Na is going to be attracted to the Cl, and that's where we get the salt from. The OH group is being attracted to the positive there, so it's going to take away this hydrogen, and that's where you get the H2O. Notice up here, you're lacking the chlorine that was once there and the hydrogen. A heterocyclic amine is one where the nitrogen is actually in the ring itself. For instance, caffeine, found in coffee beans, tea, chocolate, so on and so forth. Soft drinks, very, very prevalent. They've actually started replacing caffeine in some of the energy drinks to create an even stronger effect. So when you're looking at things like the 5-hour energy, I don't think it actually contains caffeine. I think it contains some other drug. Nicotine is another example of where the nitrogen is embedded in the ring itself. Morphine and codeine. This here is a really weird looking structure, but that is actually a ring with nitrogen in it. There's a carbon here, 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 and here. So it's actually a 6-atom ring, and nitrogen just happens to be the 6th atom. And these morphine and codeine are found in poppy plants, and you'll probably be very familiar with this if you're working in a hospital or something along those lines. Alright, so let's write the structural formula for methylpropylamine. So that means amine means that we have nitrogen in the center. Methyl means that there's only one carbon, so these are hydrogens. And propyl means that there's 3 carbons. We had to fill in the hydrogens. 1, 2, 3, 4. 1, 2, 3, 4. And then the last one gets 3 more hydrogens. There's an empty spot here, so that's automatically a hydrogen. Then we have 2-chloroaniline. Aniline is the benzene ring with a nitrogen attached to it. Because it's a 2 and not an N, that means that these other ones are hydrogens up here. And 2-chloro means 1, 2 is a chlorine. And there you go. That's the end of the amines.